Okay, so today we're looking at the area of a rectangle is 36 inches and what might the width and the length be. This really connects with two standards. It connects with area and perimeter, which is 4MD3, okay? And it also connects with factors, which is 4OA4, I believe, all right? And so when you're asked the area of a rectangle is 36 inches, what might the width and length be? I want you to make sure that you understand first off that it's talking about area, which is what? Who can tell me what area is? Belle, talk.
Area is length times width.
Okay, so we have to know that area is length times width. We know that this is a rectangle. And so not only should you connect the formula that we have here, you should also connect the rectangle of having two sets of parallel sides, and also that one side is the same length as the other side. So we've got a length here and a length here. And then the width, if you're given the width of one side, you also know the width of the other side. Those are things that you should know. That's your background knowledge, all right? So this problem tells us, okay, we've got an area of a rectangle that's 36 inches. And so we're looking for the width and the length. What could it be? So how this connects to factors is the fact that it's asking you, because we know length times width equals area, then you need to think about digits that you can multiply together in order to get a certain product. Those digits are called factors, okay? And so what factors are we going to use in order to get the product of 36? So right now at your desk, come up with a list of factors that you can get the product of 36. I'm going to go ahead and I'm going to start my T-chart because I think that that's a good strategy to use. And I'm just going to label factor 1 and factor 2. So, starting with 1, if we have the width of 1, what would our length be, Maddie? 36, absolutely. All right, what would be the next set of factors? Anybody know? All right, Kenzie, talk to me. What would it be?
2 times 18.
All right, so we should definitely have 2 times 18. And are there any other factor sets of 36?
3 times 12.
All right, 3 times 12. Now, I like the fact that we're going in order because we've got 1, and then we have 2, and then we have 3. So we're not leaving out any numbers. Okay, anybody else got one? Liz?
4 times 9.
All right, so now we have 4 times 9. And again, these are all factors of 36. And what is another one? Moses, talk to me.
6 times 6.
Absolutely, it's 6 times 6. Okay, now I'm going to stop there because that's where we can we stop there? Is there one more? Are we missing one? Ooh. So, but am I focused on that or am I focused on factors of 36? Okay, so we're focused on factors of 36. Now hold on to that thought, all right? Some of you guys are really thinking, and I'm loving that. So hold on to that thought, okay? So when we look at our factor choices, the first thing that I guess I'm going to go ahead and talk about is what you pointed out. That 6 times 6 would mean we would have a square because that would make all sides even, right, and equal. And so we know that we can't use that one because we have a rectangle, right? But let me ask you a question. Is a square a rectangle? So can we leave 6 times 6? So we can. Absolutely. Absolutely. Now, we have all these different possibilities. So we have how many possibilities? How many are up there? 1, 2, 3, 4, 5. So we have 5 possibilities. But now the question asks, which possibility gives the smallest, oh, perimeter. We've got another math vocabulary word. So somebody talk to me about what perimeter. What is perimeter? What's perimeter?
It is how many? It is length times width. Length plus width. Length plus width.
Awesome. Yeah, perimeter, and some of you are going, perimeter is the distance around, right? Area is the distance inside. Perimeter, let me change. Perimeter is the distance on the outside. You might think of a fence or the walls of our room. Okay, that's perimeter. So, you have to calculate, and technically we want to consider addition, right? Because that's like something that we've been doing forever and ever, right? And so technically we could say perimeter equals length plus width plus width. And I know that there's a lot of different formulas to do this, and some of you use different formulas, and I am cool with that, all right? But the bottom line is you need to know that we're adding up all the sides. If it's a triangle, you're adding 3 sides. If it's a pentagon, you're adding 5 sides, okay? So, given this information, given our 5 possibilities that you guys have so graciously provided, and considering that now we're working with perimeter, how do we find out what possibility gives us the smallest perimeter? How do we do that? Jayana, talk to me.
I would say you should choose the smallest number and then add itself 4 times.
Okay. So Jayana's saying choose the smallest numbers and see what comes up. This is what I'm going to suggest. Not that your idea is bad, because it's not. What I want you to do is I would like for Nate's table to calculate the 1 by 36 rectangle to see what the perimeter is. And Jaden's table is going to do the 2 by 18 to see what the perimeter is. And Kaylee's table is going to go the 3 by 12. And Moses' table is going to calculate the perimeter for the 4 by 6. And then you guys are going to do the 6 by 6. All right? And as we are calculating perimeter, I'm hoping that you're using the formula. So if I am doing the 1 by 36, I'm going to plug in 1 2 times, because I've got to consider that there are 2 lengths, and then I'm going to consider that there are 2 widths. So this is what the formula is going to look like for solving that unknown. If I'm doing the perimeter formula for 2 times 18, 2 by 18, perimeter equals 2 plus 2, because there's 2 lengths that are 2, and I'm going to consider that there are 2 widths, so I need to have 2 18s. The perimeter formula for a 3 by 12 rectangle is going to be 3 plus 3 plus 12 plus 12. The perimeter for a 4 by 9 is going to be P equals 4 plus 4 plus 9 plus 9. And the perimeter formula for a 6 by 6 is going to be 6 plus 6 plus 6 plus 6. And I'm going to get my answers. What'd you guys get?
74.
All right, so we've got 74 here. And I'm going to change colors just. So we've got a perimeter of 74. What about the 2 by 18? What is it again? Sorry?
40.
40, okay. And a 3, the 3 by 12 is?
30.
All right, 30. And the 4 by 9? 4 by 9? Do y'all have it? What is it?
26.
All right, 26. Maddie, you said, okay, I got yours 30. And then the 6 by 6 is going to be what? Somebody?
Okay, I'll do it. Which was 24.
Okay, so 24. So, what has the smallest perimeter? What has the smallest? Xavier, talk to me.
24 has the smallest perimeter, so
Yeah.
it's 6 by 6.
Correct. 24 has the smallest perimeter. It is 6 by 6. Is this the one with the smallest numbers? Yeah, okay, it is, but, I mean, 1 and 2 and 3 and 4 are small too, right? So it doesn't necessarily, you have to be careful when you say smallest numbers, all right? The surefire way to have an accurate answer is to calculate all of the options and prove your answers, okay? So again, this was a review of 4MD3, which was area and perimeter, as well as how it connects to factors of numbers.